Hello all, welcome to our channel. So in this video, we will talk about a simple voltage control circuit. What do you mean by voltage control circuit? So basically, in some of the scenarios, we can have something called a gating circuit so that it controls the power to be provided to a specific load, and whenever the power is required, then only we can enable that power supply. This helps to like save power, and also um, helps us eliminate unnecessary load on the power supply at all instances. So this is one kind of circuit where you can consider R3 as a load, okay, and this as a actual gating MOSFET, and you have another MOSFET here, which is N-channel MOSFET, which is controlled by things called microcontroller. So now, as we cannot replicate the microcontroller here, we have given a DC power supply directly, such that for N-channel, you can understand that this will be on. Now, this actually is connected, you can see here, to the gate. So now when this transistor is on, what happens is there will be a ground directly to this resistor. That means this P channel will be on. Now in another scenario where this is grounded, the N channel would be off, and then the power of 5 volts would be directly given to the gate, and then this MOSFET will be off. Okay, so that means on and off of supply to the load can be controlled by the circuit. So there are other discrete elements you see here. One is capacitor, which actually is nothing but a bypass capacitor to eliminate any noise. And then you can see a capacitor here, and then R here. This is basically a RC element which controls the voltage and eliminates the instantaneous switch on of the output supply. So in cases, what happens is when you give an input voltage and you turn on the supply instantaneously, there will be a sudden surge in current, okay, because these capacitors and then the load capacitance associated with it will try to charge, and there will be a sudden surge in current. To control that, we will slowly turn on the MOSFET rather than turning it on instantaneously. So it's not just a gating circuit, it's also controlling the power supply voltage rail. So it helps us in two scenarios. Now let us try to simulate this. Okay, so if you probe the input, it is 5 volts, and then if you probe here at the output, you can see there is 4.99. So there is definitely a drop associated. We haven't selected a ideal or low RDS on P MOSFET here. So when you're designing your circuit, you ensure that you select a low RDS on, such that this goes much closer to the 5 volts. Okay, so that's one important thing which we have to ensure in our designs. And then these components can definitely be varied as per your requirement. And now in another scenario, if you want to turn off, okay, if you want to turn off the output voltage, okay, let us connect it to ground here and then run it. You can see the output voltage is down to 0. Okay, so that's how you can see here it is 0. Okay, so that means you can control this MOSFET, make it high or low, and then correspondingly control this MOSFET and ensure that voltage is input or output to the actual ICs or whatever load that is connected. Very simple circuit with very less BOM, and very useful circuit in embedded applications where it is very commonly used. Okay, so as we said, To optimize your circuit, you can vary the R and C values and use it as per your requirement. Thank you.